Hey, what's up? Welcome back. This is day 11 of the Advent of Code, and this is called Dumbo Octopuses. We're going to be solving this with Ruby. This is 2021, and the process, or like the idea here is that you have 10 or 100 octopuses arranged in a 10 by 10 grid, and it's one of these Dumbo octopuses, which are pretty interesting looking. They've got these like Dumbo looking ears, and they look like elephants. They totally look like elephants. So yeah, we've got 100 bioluminescent Dumbo octopuses arranged in a grid, and each element in the grid represents the energy level of the octopus. And when the octopus reaches 10 or whatever, when it like crosses from a 9 up to a 10, it flashes. And what happens when it flashes is it also increases the energy level of the neighbors of that octopus. So in this case, if we started off with a grid of octopuses that looked like this, is it octopi? I don't know, some sort of plural. And we had a bunch of ones and then some nines arranged in like a square inside. As we tick or go to like the next step, then each of these nines are going to flash. And when it flashes, that means that we're going to like switch it to a 0, representing that it flashed. And we will also increase the power of all of the elements around it. So step 1 of a tick is that we're going to increase the energy level of all the octopuses by 1. Step 2 is that any octopus that flashed will also cause its neighbors to increase. So if we look at this top left corner, right, the number 3, first we increased it from 1 to 2 naturally as part of a tick. And then we increased it from 2 to 3 because its neighbor, its direct neighbor, was an octopus that flashed. This 4 increased from 1 to 4 because first it increased from 1 to 2 as part of the normal tick. And then it increased from 2 to 3 because this octopus flashed. Then it increased from 3 to 4 because this octopus flashed. And so on and so forth. So the idea is that we want to sort of track how many times we flash. And the first part here is going to be trying to figure out after 100 steps, how many total flashes are there? And so my answer was 1615. And so we are going to go through and try to implement this. And yeah, so let's jump in and get started. So we're going to add a new day 11, and this is going to be like, I don't know, octopus.rb, sure. And then we want to add a spec. Day 11 spec.rb, and this will be require relative, and it's really kind of like a grid of octopuses, but whatever, we're just gonna call it that class. I've been needing bybug in every single episode, so might as well drop it in there. Class octopus. I don't know if it's actually like an octopus, but yeah, it's whatever, it's fine. It's a grid of octopuses. I don't know what the plural of octopus is, but so these are all of the energy levels. So I think we can safely start off with a 10 by 10 grid. So we're going to say like energy or like levels or something is going to be array dot. Actually, we'll take in levels as an argument, levels, and we'll just say like we'll add a reader for levels, and I guess we also want to say like it. Flashes as expected based on the example. My it statements are getting lazier and lazier depending on how late it is in the day. So, all right, so before any steps, let's assume that we're passing this in as our argument. So this is going to be like our grid of octopuses. Let's see, octopus is octopus.new. And here's all the energy levels. And we will just start off with these in an array of arrays. And then what we want to do is we want to say like octopus.step. And then after its steps, we want to expect that octopus.grid or something, or levels, to equal this new state, which is going to be after step 1. So this is kind of, we're basically just copying and pasting from the example here. And this should help us really get started. All right, no method step for octopus. So let's go implement that now. So we're gonna have step. And what is step gonna actually do? Okay, so we expected this new state and we got the old state. And so what step is gonna do is gonna say something like, first, actually, yeah, I guess we can kind of just do exactly this. So we want to sort of just like, first, the energy level of all the octopuses increases by 1. So at levels dot each with index do rho and I guess we're going to iterate over all of these the same way and say at levels at I j plus equals 1. Okay, so let's extract this and make it a like the square bracket thing again. So let's say something like self or like def square bracket at a point I j is going to be levels at I and j, and then here we'll just say self self at I j plus equals 1. And then what I want to do is, okay, so then let's just keep going. But I think I want to extract out this thing that iterates over because I think we're going to have to do that several times. So then any octopus with an energy level greater than 9 flashes. So now what we want to do is like this same iteration, but if the value is greater than 9, then we want to flash. So something like if self at ij is greater than 9, flash like ij or something. And we'll have to write some method here that does that. But for now, we can run our test. And we need, we also need a setter method that looks something like this. And this will have like some value equals value. Run the test. Undefined method flash. Okay. We're going to have a flash that's going to take in a point ij. And this is going to, what is this going to do? So this is going to say, go through the neighbors, that is including those that are diagonally adjacent, and increases theirs. And then if it also flashes, that process continues as long as new octopuses keep having their energy level increased beyond 9. So what we want to do here is we want to say something like, go through all the neighbors and increase their energy. So something like, I guess we also want a neighbors. We want some neighbors method. So let's describe that. And we did this for a previous exercise, right? Where we had like some sort of neighbors. But let's see. So we expect the neighbors are like octopus dot neighbors of some point. So let's say like 0, 0. 0, 0. We expect those neighbors to contain exactly some numbers. So if we're at 0, 0, so if we're right here, we should expect 0, 1. We should expect 1, 1. And we should expect 1, 0. And let's see what we get. We get nothing back because neighbors doesn't exist. So let's write a method neighbors that takes in a point ij. And this is going to, again, return something that's pretty simple. So we just have to go through all of the adjacent points. I think there's like 6 of them. So this will be like I minus, or like I and j minus 1. I and j plus 1. Okay, I don't know why that was so confusing. All right, but this I think should be all of the different diagonal directions, right? 1, 2, 3, 4, 5, 6, 7, 8. and there's 3 across the top, 3 across the bottom, 1 on each side. Okay, dot select. There was also a question on one of the YouTube videos in the comments about filter versus select. Filter and select, or filter is an alias for select, so we can use filter or select here, doesn't really matter. And then we have to say like A and B, and we want A dot between 0 and at levels dot length -1, and B dot between 0 and levels dot first dot length -1. And let's see if that passes our test. Boom. All right, so let's add another expectation here. We will test out this top right corner. So this is going to be 0, 1, 2, 3, 4. Then it's going to have 2, 1. 2, 2 is itself. 2, 3 is to the right. And then below it is going to be the same, but all of these have 3s. And we're still good. Okay, so we got our neighbors. We got our neighbors figured out. All right, so what we want to do now is we want to go through all the neighbors. Neighbors of I, j, dot each do. And this is going to be a neighbor coordinate, so like x and y or something. And for all x and y, we want to say self at, actually now we can use point. Yeah, let's just do point, self at point plus equals 1. If self at point is greater than 9, then we want to flash point. Because if flashing ourselves causes us to flash a neighbor, then we want them to also kick off and like trickle down to their neighbors. And so we're going to call flash here, but this is going to cause a like recursive loop that is going to probably have like, yeah, infinite loop situation. So if we run this, yeah, so this is like a classic sign that we have an infinite loop, right? We're just like getting all this feedback and we don't have a way to stop. So what we need to do is we need to keep track of what we have flashed. So at flashed is going to be, it's going to include this new point. Let's actually just call this point. And now we can add the point to flashed, and we can return if at flashed dot includes point. I think that should stop us early. Include, oh, I guess like we got to say at, well, where do we want to initialize this? I think we want to initialize it right before we step. At flashed equals empty. Not sure. Okay. So we expected 3, 4, 5, 3, 4, 5. Okay, and we got, oh, we got this number. Okay, so here, some of these, instead of being zeros, are way bigger than zeros, right? They're 15, 10, 15, whatever. And so what we want to do is, the last step here is any octopus that flashed during this step has its energy level set to 0 as it used all of its energy to flash. Okay, so now what we need to do is after we have flash, we want to again iterate through all this stuff and say if self at ij is greater than 9, then set it to 0. And let's run our tests again. All right, now we got a passing test. So we are flashing, we're flashing as expected. So I do want to come back and refactor this, but let's keep driving on. All right, an octopus is highlighted when it's flashed, when it flashes, given the step. Here's a larger example of how it progresses, blah, blah, blah. After step 10, there have been a total of 204 flashes. Fast forwarding, here's the same configuration every 10 steps. All right, what do we need to know? After 100 steps, there have been a total of 1,656 flashes. Given the starting energy level of Dumbo octopuses in your cavern, simulate 100 steps. How many total flashes are there after 100 steps. So what I think we want to do is make some method here called like, I don't know, pass or like tick or something. I don't know. That'll take in some n, and we'll do like n times step. That way we can actually like run some certain number of steps. And then how we keep track of how many flashes there were is going to be interesting, because like after each step, I guess we need to count how many flashes there were, right? So like, yeah, so at the end, I think we might want to just like count how many flashes after every single step, and then we'll just count them up. All right, so the way we're going to do that is I'm just going to like keep track of a new instance variable called like flash count, and we'll just set it to 0. And after we actually start ticking, it's game over after that. Like once we start ticking. All right, so at levels.flatten.count 0, count all the zeros and add that to our flash count. And that should give us the answer, I think. So let's add a little test here. So we want to expect that octopus.flash count to equal 9, because this one flashed 9 times, right? So let's run it. Undefined method flash count. Run it again. Boom. All right, so that works. I think, I don't know. I mean, we only flashed 1 time, so we'll have to just roll with it and see how it goes. Okay, so what we want to do now is we want to check if it's file input. And if so, we're going to read in from the file our, actually, no, let's just use data again. Let's use data. So we'll use data.eachLine.map chomp. This is a cool trick. So if you put __ end at the bottom, you can drop in your own data. So I'm going to use the example data first before we put our own. And we'll say split each line and then grab its characters. Or no, I guess like dot map. So that's going to give us the lines. And we want to map over all of those and get the characters. That seems too easy, but let's see. Octopus. Okay, so octopus equals octopus.new, and we want to say octopus dot, what is it? Tick. And we want it to tick 100 times, I think. And then we want to put out octopus dot flash count and just see how it goes. So day 15, octopus, wait, what? No, day 11. Day 11. Day 11, octopus. Okay, boom. Cannot convert integer into string. Okay, so then this needs to be mapped again. Oh, we need to map that to lines, and then we want to map the lines each to, so that gives us a line, and then line.map to I. Unexpected local variable. Something, oh, octopus.new, that's where that paren was for. 1,656, 1,656. Okay, cool. So that's the end of part 1 for day 11 of the Advent of Code. Actually, no, hold on. Jump at the gun, hold on. Get your puzzle, come over here, grab this thing, and then what was mine? Mine was 6,000 or 1,615. 1,615. So that is totally working. Okay. It seems like the individual flashes aren't bright enough to navigate. So you might have a better option if the flashes seem to be synchronizing. So in the above example, the first time all the octopuses flash simultaneously is step 195. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Okay, so what I think we want to do now is make a method called something like all flash or something like that. It knows when all octopuses are flashing or something. And then we want to, I guess we actually want to like use the input, the example input, so that we can use the exact numbers that they used. So we know that like 195 is the number here. Okay. Okay, so then we want to say something like octopus.tick 195, and then we'll p octopus.levels and just see what happens here. So we did get all zeros, so that's cool. So then we want to say expect octopus.all flashing or something like to be all flashing. And then we have to make a method all flashing. So then we'll write a method here, all flashing. And this will just be like at levels dot flatten dot actually we have a count already somewhere, don't we? Levels dot flatten dot count. Oh, I guess, yeah, whatever. Levels dot flatten dot count 0 equals 100. That should give us like whether they're all flashing or not. Okay. And actually, you know what? We should probably make it a little bit more durable so that we're not depending on the size of the grid. So let's do at levels like dot flatten dot count. So all the the count of zeros should match the count of all elements. And that's true. So then I guess let's make it 194, and that should not be all flashing, and 195 should be all flashing. And not to be all flashing. Oh, we don't want to, yeah, okay, so we want to just tick one more. Yep, cool. So we were ticking 194 and then 195 more instead of just one more to get us to 195. All right, so that seems like it's working. Now what we want to do is we want to like find the tick at which we know that they're all flashing. So now we know how to find if they're all flashing. We know how to tick. What we don't know how to do is figure out how many steps it takes. So def, like, I don't know, full flash count or something. And then we'll just go like 0 to 1,000 dot each do X or something. And that doesn't even, actually, yeah, we just need like 1,000 times do I. And then we want to say step and if, or like return I if all flashing, something like that. And that should return the number of the step that resulted in them all flashing. So let's see if it works. Oh, wait, what is it again? What was the thing we just created? Full flash count. All right. Octopus.full flash count. And we don't want to tick at all. We just want to run it. So 248 was, oh, my answer was 249. So why are we off by 1? Yeah. Oh, you know what? Oh yeah, this should be I plus 1 because we're going to start at 0 here. times, or I is going to be, yeah, I is going to be 0 indexed. So that is going to return 249. That's right. And then if we did it for the example input, we should get 195. So we'll just grab this again and drop it in here. And we get 195. Cool. All right. So again, we did this operator overloading. I'm not super pumped about having to do all of these sort of like each with index, and it kind of like always yields a point. We're always just working directly with the point object. We're not working with anything other than like anything fancy other than the point object. So what I wanted to do was just kind of like add one more method in here and call it like each, I don't know, coordinate or something like that. And this is just going to be a helper that takes in a block and it calls the block with a point ij, because we don't actually need the value at that position. But we technically, I guess we technically could. We could pass the value also. So let's do that. So then we should be able to refactor this and say like each coordinate do like chord or point or something. And then now we should be able to just like replace it with that. Actually, let's comment it so that you can see the old stuff. And then instead of passing this array around, we can pass around the point. So each coordinate do point, and then we're going to increment by 1. And then down here, we're going to say each coordinate. Actually, let's see if our stuff still works. And it does. Okay, each coordinate do point. And then we can pull this up here, comment this out. What's cool about this is that we're writing our own method that takes in a block. So this is a nice use case for when you might write your own method that takes a block. And notice that like by default here, if I'm only passing one argument, or I'm only like accepting one argument in the block, then only the first argument that I'm calling the block with is actually receiving that argument. So then point here is just going to be ij. If I said point like comma value or something, then I would also get the value in that position. And so we're going to see that in just a sec here. So first we're going to iterate through all of them and increment by 1. Actually, yeah, let's just remove this. And then we're going to iterate through each of them. And we have the point again. And if we wanted to, we can say self at pt, give me this thing, flash pt. That really simplifies it. Run all of our tests again. And those are still passing. There is a little bit of a cost when you are passing blocks around like this, but whatever, who cares? But what I wanted to show here is that this is actually simplified because we can say value. And now instead of having to reach into self at pt, we can just say value. If value is greater than 9, then flash. And we can actually make this a one-liner, flash the pt if the value is greater than 9. So that's kind of cute. I like that a lot. All right, what else we got down here? So this one is another example where we will probably want the value, right? And so 3yy, boom. So here we can say self at point is set to 0, and then this becomes value. And then we comment this out. The nice thing about these tests is it lets you refactor like super, super quickly, right? So now we can actually just remove this, and we can remove this. And it makes it so much easier to read, right? Like self at pt equals 0 if that thing. And now our step totally follows exactly what the instructions say, and it's super tight. Yeah, I don't know. I really like it. So that is a way that you can sort of like implement a method that accepts a block and then calls that block with one or many arguments, and then you don't actually have to use them all. You can just use some of them. And so, yeah, I kind of picked 1,000 here arbitrarily, but I had a sense that it's probably going to be less than 1,000 flashes. So that's where we're at. I guess, is there any other, no, this was already sort of cleaned up. We have point that comes into flash. And then for each neighbor, we call the neighbor PT, but maybe this can be like neighbor point or something. But this is pretty good. I'm happy with this. So let's call it there. And yeah, hopefully this was useful. And if you are doing the advent of code, I would love to see your solutions. Please drop them down in the comment section below so we can all take a look. I do plan on going back to all these exercises and backfilling with links to GitHub. I just haven't done it, so it'll be up soon. So thanks so much for watching, and we'll see you in the next one.